Okay. So it's been in existence, I mean the NXG mice, for the past 20 some years already, right?
Yeah.
Yeah. So apparently this model has made tremendous contribution to life sciences research and drug discovery, and also, in translational research, right? Can you name, one drug that is developed, by using this model?
Because the primary use of NSG and OG or NKG is for engrafting of human cells, and one of which is the immune cell. So one thing that really comes to my mind would be Kymriah, which is the first CAR T therapy being approved by FDA in 2017.
Oh yeah,
so,
of course.
And you may know the girl whose name is Emily Whitehead.
Yes, yes.
So she received.
She's still around.
Yeah, she's
healthy.
She's healthy, but she was the first one who received the CAR T therapy back in 2012.
That's how many years ago?
That's 13 years ago.
Wow.
Now she's cancer-free, and every year she took a picture of herself. Like
I know
last
that,
year,
yes.
so last year was this year was 13 years cancer-free.
That's a big inspiration.
Yeah, that's a big moment. So she received the CAR T therapy back in 2012, back at CHOP, Children's Hospital of Philadelphia, by Cyagen's group. By the way, Cyagen also is a mouse researcher, so he runs a research lab. So before that CAR T drug was given to Emily in 2012, it was a year ago that Cyagen published the paper. What he did is that he used the NSG mice for an engraftment of a very aggressive tumor cell line into the NSG mice, and because the tumor cell line expressed the CD19 marker, and then he put in the CD19 CAR T into the NSG mice, and within a day, because the cells are fluorescently labeled, they can see the tumor cells are disappearing.
Okay.
And then it was quickly moved into clinics.
Wow.
Yeah, that would I would say the eureka moment for Cyagen's group and for the field.
So it's the best, one of the best translation.
Yeah.
Into human.
Right.
Okay. Yeah. I mean, this is only one out of countless examples of this model, making contribution to research, right?
Right, and because I mentioned immuno-oncology, that's been primarily used for, but besides immuno-oncology, the humanized mice can also be used, say, for study of autoimmune diseases.
Yes.
Because one seminal paper that came up about a few years ago is that people can draw the blood from SLE patient and put it into the NKG mice or similar, and they can find that the mice will develop several features of SLE patient that include development anti-double-stranded DNA and also nephropathology. So it's not only in the immuno-oncology. And the other example is that mouse model has been known difficult to study HIV.
HIV?
Right.
Wow.
So because the mice has the capability to repopulate the human immune cells, so in order for HIV to enter into the body, it binds to the receptor called the CXCR4 or CCR5, but it cannot bind to the mouse counterpart. But when you have a human immune cells, especially the CD4 T cells, that's like the target cell for HIV.
Yeah.
The people can study HIV in the context of a mouse.
Okay.
So immuno-oncology is one example, but it's been widely used in multiple different research areas.
Yeah.